Hello, this is Alan. This is my most recent programming project. It's a Rubik's Cube simulator written in C++. So real quick, I'll demonstrate how it works. Alright, so put in my name. Here's my Rubik's Cube. It pulls up a save file based off of my name, so it recognized my name and pulled up my Rubik's Cube. So you can see here I've already started on it. I've rotated it once right along the center of the Rubik's Cube. And since I haven't really learned how to make graphics yet in C++, it's just using letter abbreviations, so like B for blue, W for white, Y for yellow, O for orange, R for red, and G for green. But it works. It's a little confusing, so it's not ideal, but it's working for now. At least I have a Rubik's Cube, and I can move it. So like, for example, if I want to move twice, so I'm moving a piece 2 times, and I'm going to pick the x-axis, and I want to move the center. That way we have a nice little crisscross in our cube. So now you can see I've shifted along the x-axis and got almost a complete crisscross here. And I can complete it by doing the same thing along the z-axis. And we'll go along the center. And there we go. We got a perfect crisscross. And then, of course, I can put it all back. Let's see. And then, see, it's the z-axis that needs to be fixed still, so. There we go. Oh, it is not all solved. Oh, oops, that's why. I moved the back instead of the center. Well, I can just move the front now. Okay. It helps if I put in the correct buttons, correct input. Okay, so we'll go along the z-axis. And now we'll move the closest one since I've already moved the other 2. And there, now it's all solved. Upside down from how I meant to solve it, but it is solved. And so yeah, that's my code. And then, so you can see as here, we have it here, the green's on the top and blue's on the bottom. And so if I were to close my code and run it again, I could make up a new name. Now we have a file for Bob. And as you can see, my default, I just have blue on the top and green at the bottom. And if we were to close this, and if I were to pull up my own name again, it reimbursed mine, which has green at the top and blue at the bottom. So, very nice, very convenient. So you can have multiple Rubik's Cubes all set up under different names. And you can just leave it the way you found it. So if you have your cube that you just don't know how to solve or you can't solve and you just want to leave it alone, and whenever you exit the file it saves, so it can just pick up right where you left off. Or if you want to start from scratch, you just make up a new name and do it under a new name. So pretty fun. Alright, so we'll take a look at how the code works. So I haven't learned how to use header files yet in C++. I learned how to use C like 2 years ago, and I used header files back then, but I've forgotten how header files work. So as a result, it's all in one really messy single file today. And it's on my to-do list to fix that and organize the classes into different files. But until then, you see here's the libraries I'm using. Technically, I don't think I'm using S-stream anymore, so that one probably doesn't need to be there. But the rest of these, I got the file stream, I'm using queues, I'm using strings, and I'm using the in-out stream. So I had some fun today using the enumerations, where I just made a list of values, and it's helpful for keeping the code straight. I did find that using enumerations also had the catch where I was very, very reliant on switch case. So it came with its pros and cons. But at the very least, it made my code a lot more readable, and for making the Rubik's Cube, I think making the readability was important. You see I made a structure called a side that constitutes a piece of a Rubik's Cube. And so it consists of a constant color and then an orientation. And then, of course, you have the Rubik's Cube itself, which is a vector of sides. So a vector is for those who haven't used a vector before, it's like a changeable array. Because I made it changeable because you don't know really when I'm making these classes if it's going to be a one-sided, two-sided, or three-sided piece. So I got a whole bunch of helper functions here. They're not really that important. They just help the inside of it work. And they help. This one, for example, helps for when I'm saving it to a file. Let's see. This one is how things are being displayed. And eventually, I wanted to replace this function altogether with some actual graphics, but you can see it's just using switch case, and if it sees the color it's looking for, then it prints it out. We have a nice little error 1, 2, where if it, for whatever reason, you don't have a color or not color that we're expecting, then it will just print out an X, and that's been helping me with just finding things that aren't working the way they're supposed to be. This whole get string is mostly for writing to files, so I can put it all in a CSV file. Okay, here's a rotation 1, so this helps the piece just know that if it's been rotated, it needs to know that the direction associated with that color of the piece in the vector needs to be now facing a different way. And I had to use a lot of switch case for this function. Not sure, I think if I had used like some kind of higher order function, lambda functions for example, then maybe I could have found an easier way to do this, but yeah, it's just a lot of switch case. Okay, here's my child classes, which at the moment are really simple because they really just have different constructors. So really I didn't even need to make child classes for this, but I did end up making child classes. So, and I could have just made different constructors. It does help too for polymorphism. If I wanted to see what type it is, I can say look for check if it's a single-sided piece, double-sided, triple-sided. But yeah, the child classes are really simple right now because they really do have the same behavior and properties, or at least except for the fact that some just have more sides than the other. Here's my most important class, the Rubik's Cube class. Got a whole bunch of enumerations here just to keep track of where things are when in my own code. Here is my little helper function for when I'm making a new piece. Got the new keyword here, and I've got some making some dynamic classes that just using the new constructor and pointers. So you can see I'm using a lot of references too. I'm using a pointer reference here instead of just the dot. I reference the pointer. Let's see, what else have we got here? Yeah, I think you really get used to using the standard library thing and just calling it. I could have used the using keyword, but I wanted to avoid that in case I caused chaos to my code. So I just had to use std a lot, and it was a little tedious, but it got through. So yeah, you can see a lot of switch case. In this case here, this function here is reading from the file and turning it back into a cube that my code can recognize. See, I got a runtime error. I haven't actually triggered this error, but I figured it was good to have just in case some kind of orientation that wasn't expected was in there. Here we are again with converting the colors from this file into something we can recognize. Alright, here is my really obnoxious constructor. So I got some for loops. Just loop through the three-dimensional array. Oh yeah, I forgot to mention that part. So yeah, the basis of the program all revolves around this three-dimensional array right here. This three-dimensional array stores everything that's relevant to the Rubik's Cube. And it's the main bit of data for the Rubik's Cube class. And all the pieces are added as parts of the three-dimensional array. So yeah, here's my constructor where I loop through. I had to redo this constructor quite a few times and got a little better with it each time. But so yeah, here I'm using a queue. I found queues really useful for this. So I just push whatever it is I need to add, and then I know that each cube I'm going to be adding either a left or a right, and then or just not adding at all, but there'll be either left or right. There's definitely not both, so I just checked to see if it was left or right and add it. And what we were looking at here is the generic constructor in case it's a new file. Up or down, in or out, and of course if that has not been pushed at all, if it's in the center instead of the near or far part of the cube, then it just doesn't push it at all, and my code later on recognizes back in my new piece function that I had earlier, wherever it went. Yeah, this is the drawback of not making header files and putting my code all into different documents. It's all one massive 1,000 lines of code, and it is hard to find anything. Let's use the search function. My search function is not... Oh, that's because I... Here we are. Yeah. So this one will take that same queue, or rather it's taking the pointer to the queue, and now it's popping, it looks at the size and says, oh, it's a three-sided queue. Okay, so we'll make a three-sided piece and add it to the, return the pointer to that piece to the array that was in the code before, wherever that went. Right around here. Wait, no, that's my file saving stuff. Oh, here's my constructor. So yeah, so you can see right there. There we are, back where I was. So here's the old way I had it written out. I used to just have it line by line, and I realized, wow, that's hard to edit, and if I made a mistake, where will I find it? But yeah, this for loop does what's right here. And it's just, this is very specific, but it's not very flexible. Well, yeah, there are pros and cons to both ways, but I went with that way up top. Alright, here's my other constructor that does it using a file. And for the sake of time, we'll gloss over that today, but needless to say, this file here, or this function here, took me a couple hours to work, as I had to learn how to make files. It was a pain in the neck, but I got it done in the end. But yeah, basically follows the same logic, just gets the information from a file instead of through my pre-written stuff. But yeah, here's my display function, loops through, checks which sided it is. And yeah, for the sake of time, let's just skip over it. But yeah, lots of arrays, lots of switch cases. Here's my shifting one, where I shift all the corners of the cube, and I shift the center of the cube. And then I had to write several cases depending on which axis we were shifting along. This is, I think, one of my most inefficiently written codes I've ever written. I had to write so much stuff multiple times. At least this one I could take some shortcuts. I'm going to write some more efficient ways to do it eventually, but it works. And so yeah, that's my code. And here's my main file, but yeah, that's pretty much everything. So thank you for watching.